Ni hao, good morning. Uh, Thank you for the honor of speaking at the inaugural Ceph conference. My name is Tushar Gohad. Uh, I work in the capacity of principal engineer at Intel. My focus has been software-defined storage for the last 5+ years now. As part of leading these efforts at Intel, I've been involved with OpenStack, Ceph, as well as a few other storage technologies, including network-attached storage for media. Today, I would like to talk to you about extending Ceph's reach beyond where it is today. So let's talk about, as Sage would say, future of storage. So now is the time of intense amounts of data, and it's only going to get worse. Or because we are all working on Ceph, maybe better. So as the scientist John Lilly of dolphin and human sensor research fame once said, the only security that we have is our ability to change. So at Intel, we embrace these new challenges as we have invested in exciting new hardware as well as software technologies, including Ceph. So here's his vision for Ceph at Intel. As I said, we want to expand Ceph's reach, bringing new workloads to Ceph. We have been a responsible community citizen, and we are actually working on growing it or making it better. Our Ceph efforts have been following our open source commitment. As you may know, we have been the top Linux kernel contributor for several years now, and based particularly with Ceph, we have an 8-strong team of open source developers that have been working on various areas. And we also work with OEM and ISV partners such as Red Hat and SUSE and Canonical on helping their customers adopt Ceph for various usages. So let's look at where the data growth is coming from. So we are starting off with an average internet user producing 10 gigabytes a day. But if you look at extending it to smart factories, that amount extends to a petabyte a day. Or as Google's research would tell you, a smart car of the future would basically produce a gigabyte a second, which amounts to 4 terabytes a day. So all of this growth is fueling the demand for capable storage stacks like Ceph. And there's a reason why we are in Beijing today. It's because China is a big part of this growth story. If you look at some of the recent market research reports, they tell us that public cloud is growing at the CAGR it has been, or the growth rates it has been. But what you should take note of is, private and hybrid clouds are growing at a pace even faster. So if you see the trends, private cloud is growing at 24%, and hybrid cloud is growing at 26%. So as a whole, it becomes essential that we basically have a solution that's open, that powers these growing clouds. So let's take a look at who's using Ceph today. So the logo wall, as I call it, these essentially all the companies that are deploying Ceph today or actively looking to, that we've been working together with. So one common theme that you would notice across this logo wall is that these are all data companies, as I would call it. These are the companies whose business is to store, process, analyze, or deliver data. These are the companies that had to make transition to open source, scale out, Ceph, to meet their challenges of growing workloads and growing data demands, and doing so in a cost-effective manner. Now, these companies have smaller armies of engineers, of expert Ceph users, or DevOps in many cases. And that's why they're able to do what they need to. But there are many companies outside of this list that that would basically fall into the private or hybrid cloud category that we need to make Ceph more accessible to. So let's talk about the technology behind all this. So, my apologies. So, okay. This isn't working either. Yeah. Okay. Okay. Thank you. Okay. All right. So once we have the display back, but I'll keep talking in the interest of time. So let's look at some of the technology behind this, and in particular, what Intel has been doing in the context of Ceph. So Intel's Ceph contributions or involvement with the Ceph community dates back to about 2013. We have contributed features in, like I would say, our contributions to Ceph fall in 3 buckets: performance, features, and manageability. So we contributed to erasure coding as one of the first features. We did also work with the community for integration of various offloads into Blue Store. But let me focus on what we're doing today with the community. So as Sage touched upon during his talk, non-volatile memory is the big theme, right? So we are working with the community on applying non-volatile memory programming models to the asynchronous OST. As I laid out earlier, Ceph, in order to bring low latency workloads to Ceph, client-side optimizations is a key. Essentially, one of the key areas that we are looking at is to cache data closer to the application on the client, so that we can reduce the latency that's brought over by the network as well as the OSTs. And the third category of workloads to the right is essentially we are working on working with the community on compression and encryption support, for example, for exposing those offloads that some of the newer Intel platforms provide. Now, I want to talk to you about three trends and why they're important going forward for Ceph. We share this vision with Sage and the community. And again, kind of making the point here, I won't spend too much time on this slide because as you guys know, we're transitioning towards non-volatile memory. So what this chart shows though is if you look at the green portion of each of these bar charts, from left to right, what we've shown is the latency for hard drive media, going down to 3D crosspoint, which is the fourth bar to the right. What's changing about storage is that the system software as a percentage of the total I/O latency is growing. So essentially, in the hard drive days, even if you made your software latency to 0, it did not matter because you had milliseconds of latency to the media. With 3D crosspoint or Optane media that Intel has introduced, that latency for just the media is in the sub 10 microseconds, which basically is going to make us think or rethink software stacks as they've been written. So what has Intel been doing about this? So a few of these acronyms, DPDK, SPDK, PMDK, have come up. Many of you may be familiar with it. But these are the development kits that Intel is putting out there as the foundational building blocks for non-volatile memory programming model, as well as asynchronous pole mode lockless primitives to make the network or networked storage stacks go faster. These are all open source projects. They have been communities for a while. So DPDK has been around for 2008, which opened up the high-performance routers market to the standard x86 platforms. SPDK is in fact the team that I belong to. We have a thriving community for about 3 years now. And in fact, we have an SPDK summit right now going on, co-located with this in Beijing. Intel Intelligent Storage Acceleration Library, these are primitives that many of you that have used erasure coding or compression with Ceph have probably put to use already. But the next wave is with persistent memory, which is essentially bringing storage or memory closer to processor than even before. We recently renamed our PMEM, which is persistent memory library for block object as well as byte addressable programming models, to PMDK in the same spirit as DPDK and SPDK. So these are the components that are at the disposal of the community. Intel is investing a lot of resources to keep these communities alive and growing. So the call to action for the community is to put these to use in making Ceph better. The second theme, which some of you may be familiar with, that I want to talk about is disaggregation. So if you look at today's data centers, they're based on homogeneous servers. So if you take a look at, let's say, a hyper-converged or typical data center deployment, even with disaggregation with Ceph, you will see that every node that is deployed has certain compute, network, storage, as well as accelerator elements. When there is a need to upgrade, so I'll give you an example. So let's say you are running an AI workload, artificial intelligence workload that makes use of FPGAs or discrete accelerators like GPUs. And let's say you have the need to scale. You would typically buy a new server with multiple FPGAs or accelerators in them. Intel actually has been working on an open spec to change this picture, and the reason why you do that is because in data centers, with the homogeneous server model, the efficiency rates for compute, storage, or network, or accelerator usage for that matter, are in the lower 10%. So what if, instead of looking at data centers or the servers in the rack as homogeneous servers, if we could essentially disaggregate, and what this means I'll explain in a second, which is to pool resources as network, compute, storage, and accelerators, and give users the ability to compose nodes on the fly depending on their workload requirements. So I've shown an example here where I was able to compose a node which needed fast SSD storage and only a couple of compute units. But then I might have another workload which benefits more from accelerators, but it's not as storage intensive, where I'm able to compose node in a different way. So this is basically under the rack scale design umbrella, which is an open standard that Intel is developing. The goal is to simplify data centers by being able to pool resources into network, compute, storage, and accelerators, and be able to compose nodes for increasing costs, efficiency of data centers. Why does this matter to Ceph, right? So, because if you have pooled storage, Ceph does work today. You can make it work in a sense. But when you look at how storage disaggregation will be done in the future, the next wave that we see coming is the idea of NVMe or fabrics, which is analogous to the iSCSI word, where you essentially transported SCSI commands over Ethernet. Going forward, we see direct attached storage in the NVMe Express, NVMe Express format, and pooled using RDMA or TCP, like Fabric, with the protocol being NVMe or fabrics. So this model actually brings a lot of goodness, which is essentially the ability to scale compute and storage independent of each other. It does let us do a few interesting things with a storage stack like Ceph. So imagine for a second that you're your OSDs and NVMe SSDs were not in the same box, in the sense that they are not statically mapped to each other. An OSD runs as a stateless unit on a compute node, and it maps to remote NVMe devices as needed. So in a containerized environment, for example, this actually this enables some beautiful scenarios where you could either failover, you could make a node serviceable by simply migrating a stateless OST to another node to save power. It could be you're running out of CPU cores on that node, and your OST is a high performance OST that's just core hungry. You want to migrate it to another node. You could do that with by simply remapping your storage to another NVMe or Fabrics node. So again, the message here is that Ceph is able to work in this mode today. But if you look at the holistic rack scale design management or data center management, there are two standards at the heart of it. There is Redfish, which is a standard that we are driving with DMTF, which is a body that's basically looking at the composability at the hardware level, and Swordfish, which is essentially a network and storage configuration management layer on top of that. So imagine being able to provision OSTs at the hardware level with Redfish, and Swordfish would allow you to create storage pools from, let's say, RBD. So we need to see how Ceph fits in this picture. So there's some work to be done in this area. And talking about Redfish and Swordfish brings us to the topic of manageability that Sage touched upon. So in the short term, to make it very impactful, we need to make sure that manageability is the key area we focus on. So it's not just about the provisioning or day one install. It's really about day two. As your workload grows, we need to make sure that monitoring, alerting, and tuning, some of those workflows are automated. To streamline provisioning, we talked about having a large number of tuning parameters. We need to figure out how to expose those to your standard storage admin, who is not a developer, that they understand and be able to use those effectively. The tool ecosystem has been fragmented, but in-tree efforts like the Ceph Manager are headed in the right direction, we think. And we really need to spend some time on diagnostics and troubleshooting. So in that sense, we do share the vision with the community and Red Hat. So talking about talking about data companies and private and hybrid cloud deployments, where we as developers, where do we find the motivation? So I wanted to talk to you about a story where Ceph has been the force for good, in a sense. So Intel has been working on a few initiatives where we're trying to apply AI, artificial intelligence, for the good, or to make the world a better place. One of those programs is called Safer Children Outside. So this is driven with a nonprofit out of Washington, D.C. in the United States called National Center for Missing and Exploited Children. This is basically a nonprofit that I have had some personal involvement with in their use of Ceph, and that's why I chose this story to share with you. So this is a nonprofit whose mission is to find missing children and, in general, prevent child victimization. This is a growing problem across the world, as we know. So National Center for Missing and Exploited Children, they work as a clearinghouse for these victims, their families, and to help the law enforcement in essentially avoiding child victimization. So what's the role of IT at this nonprofit? So obviously IT has to do things IT enables, but it also has to support their mission. So they, given this is an analytics workload, this nonprofit had large sets of data to analyze. They had growing storage needs, just like every other company out there in the space, and it was becoming difficult to scale with the funding that they could afford. So the motivation for looking at an alternate storage stack again was to grow the capacity to effectively infinitely, make sure that Ceph actually, or Ceph or another storage stack essentially integrated into their environment with the need to minimally changing their applications. Supportability, they needed an ISV or a community or thriving ecosystem to reach out to in case they needed support. And they wanted to be sure that the platform that they chose supported their future needs for their varying workloads. So, of course, we chose Ceph as a replacement for their current enterprise environment. And one of the highlights of this effort was this is one of the first Cephfs in production deployments that we have worked on. So not just that National Center for Missing and Exploited Children has switched to Cephfs, they have been able to optimize their database backups and restore times from hours to minutes. They've been able to contain costs by moving to a standard server model. And they're running their large data sets happily on Cephfs. Again, this nonprofit thankfully had a couple of DevOps that were sort of expert users of OpenStack already, which is why we were able to get them here. But here's what they said for people to the people that are considering Ceph. So essentially, they talk about demoing it, trying it, talking to a friend, consultant, the community, right? Essentially making use of the APIs, Ceph APIs, which they're talking about the new Ceph Manager features, and they've been using it with Sensu for monitoring, which has worked great for them. But their message to the Ceph community is, I'll read it out for you. National Center for Missing and Exploited Children relies on open source tools like Ceph and the community that supports them every day. Without your creations, we couldn't do many of the things that we do. So thank you. So for all of you that enabled such organizations to do or fulfill their mission, you should be really proud of yourself. So I'll leave you with the familiar message, which is keep innovating. We want to be able to get into new workloads. Databases and AI are those workloads we have been looking at for a while, and with the asynchronous OST efforts that Sage talked about with C star, DPDK, SPDK, as well as some of the client-side caching work that we're doing, we are going to get there. We know the non-volatile memory is here, so we need to embrace those new programming models. Disaggregation we see as the theme of the next generation data center, and we need to get ready to make sure Ceph actually fits that picture. And last but not the least, we need to lower the barrier for adoption for all those companies that are wanting to move to Ceph. So again, thank you for all you've done. We look forward to continuing this partnership with the community and helping make Ceph better. 谢谢, thank you. So I would like to invite Mr. Zhong Xin, who is the Vice President and General Manager of Cloud Business at HNA Group. So at HNA Group, they have been deploying Ceph for a while now for a variety of use cases, including video, infrastructure as a service, as well as hyper-converged for branch office applications. So Mr. Zhong is to tell us about their Ceph journey. Thank you.
我是来自海航一建科技的中心。那么我先简要介绍一下我们海航的一个大概情况。大家也知道海航是一个全球性的一个企业了。我们在去年2017年的时候，我们在世界500强的时候能够排到170位。我们大概在全球有40万左右的员工。所以我们其实也是从2010年开始就建设我们自己的数据中心，那么也从2013年开始也开始了我们自己云平台的研发。那么我们 的整个的基础架构是基于我们国内在北京和海口的这个2地3中心的一个基础架构。那么在全球范围内呢，我们是跟很多的这个公有云的厂商去合作来布局我们的资源，因为我们这个员工呢分散在全球各地，所以呢，我们需要当这个员工，尤其是很多的高管在全球范围内去访问我们的这个整个的这个 IT 的这些应用的时候，希望他们有一个很好的一个体验。那么我们就需要有一些这个在全球范围内网络这个自动接入，然后能够让这个请求返回到我们内地的这个2地3中心的这个数据中心之上。那么同时呢，我们也是一直在持续的对我们2地3中心之内的所有的这些 IT 的这个物理资源进行这个云化的这个改造和迁移。那么我们目前呢是在今年上半年，可能我们这个所有的应用80%，也就是将近700套以上的这个应用都可以迁移到这个云上。那么今天这个场合呢，肯定主要是讲这个跟开源和这个 Ceph 相关的一些话题。那么同时我们在这块也有一些我们自己的一些想法，因为其实就是尤其是最近几年，我们感受到了几个趋势。因为其实本身我本人也是在之前在一些互联网公司把这个一些开源技术也做了很多的实践。那么我们越来越看到，其实有2个很主要的一个趋势吧。一个就是说在整个的基础架构的这个领域呢，开源已经成为了一种主流，甚至说可以说是成为了一种技术上的一种标准。像这个 OpenStack 呀、Ceph 啊、Kubernetes 啊，应该说大家这个在这个开源社区里用一种共享的方式去协作，一起去开发，然后来满足自己各个企业的这种 IT 的这种IT 业务的这种需求。那么同时呢，我们还看到另外一个趋势，就是说其实很多的这个开源的技术它本身刚开始脱胎于一些的互联网公司，可能它在一些互联网的这种高并发呀，这种一些这样的这个场景之下，它得到了很好的应用。那么慢慢呢，就是更多的来进入到企业级的这种应用，尤其像在海航的这个场景之下，海航是一个有着很多个这个产业的业态，包括像大家都知道的航空啊，但是其实我们还有更多的像地产啊、金融啊，包括科技，有很多的业务板块。那么我们希望把这些开源的技术能够集成起来，能够在海航通过支撑这么多的不同的行业的应用，然后能够把它打造成一个更好的一个云平台。那么我们也总结出来核心的有这么3点，我们把它总结成一个叫欧米伽的一个理念。那么最核心的有3点，一个是 Open， 一个是 Modular， 还有一个是这个Evolving 和这个 Enterprise。Open 就是其实我们希望它是一个开放的云平台，能够集成很多的一些开源的组件。那么同时呢，我们希望这些开源的组件在我们这个云平台上面，它是一种模块化的。那么我们可以随着这些开源技术的演进，我们可以不断的去迭代。那么另外就是说，企业就是我们希望能够把这些开源的技术能够更好的应用在我们企业的这些应用的这个支撑之上。那么这是我们基于刚才说的这个理念，我们设计、规划和实现的一个我们整个海航的 Eking Cloud 的这个产品体系。那么一方面呢，其实是我们在海航的这个实践是海航是一个这种大型的这种企业集团了。那么我们其实是有一套这个完备的我们的一套产品体系，有这个基于 OpenStack 的这个 AS， 然后基于 Ceph 的这个云存储平台，然后包括基于 Kubernetes 这个容器平台，还有我们自己研发的对接了去管理整个的我们的公有云、私有云，包括这些可能以前 Legacy 的一些 VMware 很多的这种一些传统的一些这个云资源的一个云管平台。那么另外我们也看到，其实像因为最近大家知道这个超融合也是一个方向，就是我们也看到其实像类似于海航这样的大型企业，其实它有很多的这个分支机构和远程机构。那么我们也这个设计和开发了一套能够把计算和存储能够集成在一起的超融合的一套方案，能够更好的去在一些这种小型的这种环境下面去使用的一套云的这个产品的方案。那么这就是我们的一个，那么大家可以看到，在这个图里面，其实 Ceph 是处于一个非常核心的位置，因为其实在海航这个环境下，我们既要支撑很多的这种所谓的就是 Gartner 讲的这个双模也好，双态也好，就是一个更多的一些原来传统企业的一些这种内部的这种稳态的应用。那么同时，我们其实也有很多的互联网金融啊、电商啊很多的业务需要去支撑一些这个容器啊，像 Kubernetes 这样的一些敏态的应用。那么 Ceph 其实在这个中间是处于一个非常核心的一个地位。那么最后我再来 聊一下那个我们海航跟英特尔这边的一些合作，因为其实本身我自己也是在英特尔 OTC 工作过一段时间，那么我们一直也是跟英特尔有着这个很好的合作关系。那么其实英特尔本身是一个技术驱动的公司啊，它在这个大家都知道，它在这个计算、存储、网络每一块都有这种很核心的这种底层的研发。那么在 Ceph 的这些使用场景里面，其实也有很多的需求，比如说像这个大家都知道 Ceph 里有这个 Area Coding 技术是吧？它能够在这个3副本的这种可靠性的基础上，只需要可能1.5倍左右的这种数据的冗余，但是同时它也会带来很多计算的这种开销。那么英特尔有这个底层的这种 SA 的这种 library 这种加速技术，能够帮你去一定程度上去减轻这种开销。那么同时我们在这个我们的云存储里面也是用到了这种数据加密的功能来保存一些我们核心的数据。那么这块呢，其实它也是会有一些额外的一些这个 CPU 的开销。那么英特尔在这块也提供了这个 QAT 的技术，能够帮助我们去降低这种开销，加速这个性能。那么另外大家都知道，其实刚才前面的场合，很多人也很多这个专家也都提到了，未来大家都知道闪存的这个价格也是持续在下降，未来这个全闪存也是未来的一个主流的一个方向。那么其实，在一些很核心的应用，比如说像这种数据库啊，这些对 LPS 要求比较高的应用上，其实我们也希望那个 Ceph 能有更好的表现。那么我们也跟英特尔一起在英特尔很多的这种SSD 上面做过这种性能测试调优，包括这种 spec 的验证。那么总而言之呢，就是我们希望未来能够跟英特尔一起，那么在海航的这么多的企业应用场景下，能够持续的回馈社区，然后能够大家一块儿跟在座的各位一起把Ceph社区做大做强。好，谢谢大家。